to help you detect them. So let's go through, I guess, any questions? And then we'll go through an example. This is where we're going to get into, in this case, we're going to focus on two categorical variables in the interactions. Anyway, so this example is going to look at two, see how I'm all discombobulated. So anyway, so for now, let's go through an example where we're looking at two categorical variables. And kind of the idea with this is just to illustrate how to go through when you've got all these, if you do a multiple regression analysis where you've got like 4 categories of this and 2 categories of that, and then you do the interaction, you have to multiply everything, you can end up with a lot of variables in the regression model. And trying to make sense of what each of them are telling you, it can seem intimidating, but if you approach it systematically, and that's kind of what we're going to do with this, you can start to see there's a pattern to being able to make sense of what does that coefficient tell me. Every coefficient is telling you something. It's telling you something about one of your groups. It's telling you something about one of the continuous variables. It's telling you something about differences between them and them. They're all telling you something, and you just approach it systematically, and it's doable. You can make sense. This is where people mess up a lot because they don't, and they just kind of jump to something instead of, they'll try to focus on one thing that they think is the important one and not look at the whole big picture. So we'll go through kind of a step by step, and by the end it'll be a little repetitious, but by the end you should be able to start to see, oh yeah, I get it. I see how we do this. So for this example, we're looking at 80 kids, equally divided males and females, and equally divided into either homeschooling, religious schools, private schools, or public schools. So we got a dichotomous variable, 2 levels, and a categorical variable with 4 levels. Our outcome is going to be academic performance on a 20-point scale. And we're going to do dummy coding to keep things, again, very straightforward and interpretable. This is what's nice with dummy coding. Gender is going to be, a kind of dummy code. As we said, 0, 1. And then school type, we're going to use the public schools as our referent group. So visually, this is what our data would look like. If we had each row is one student, one kid. And so if we have a male, here we have a male who's in religious schooling, right? So we have their gender, and then here's the 3 dummy codes for their type of school. So, right? So gender, and then these 3 dummy codes are their school, are which type of school, right? 4 groups, 3 dummy codes. So if I'm male and in a religious school,
no, female.
I'm sorry, I'm female. If I'm female, because it's coded 0. If I'm female in a religious school, I then need to calculate my interaction between gender and school type. And we talked about it before, you just multiply the 2 terms, the 2 variables. Well, in this case, it's a little messier, you may kind of think, because I've got 1 variable here, but school type is 3 variables. Is that still ringing?
Yes.
I turned it down. Look.
Just turn it off.
I turned it off. I turned it down. Gosh. Power off. Tap again to turn off your phone. So you might think okay, so we have gender, and then school type is 3 dummy codes. So to do the interaction, we have to do gender times each of those dummy codes. It's the same idea. You multiply the 2 variables, but in this case, because we're multiplying a categorical variable, you have to multiply it by each variable in that category, each dummy code that makes up that categorical variable. So we need to make a variable that's gender times religious school, gender times homeschool, and gender times private school. So these 3 variables are our interaction. in the exact same way that these three variables are what school are you attending. These three variables tell you, does the school effect change based on gender? Or does the school effect vary based on gender? Right? It's the same idea. That all three of those are the interaction. It's not one. People make that mistake all the time. That they'll say, I'm looking at this is my interaction. That's a dummy variable that's part of the interaction, but all three of them are the complete interaction effect. So again, if I'm looking at a female who's in religious school, then what's the interaction going to be? Well, it's going to be 0 times 1, 0, 0 times 0, 0, 0 times 0, 0, right? A bunch of zeros. A female in a homeschooling, it's 0 times 0, 0 times 0, 0 times 0, it's all zeros again. Female in a private school, 0 times 0, 0 times 0, 0 times 1 is still 0. So for female, notice they're all still going to be zeros up there. Well, and female in the public school is all zeros times all zero, so 0 times all zeros. So for female, everything over there is 0. Then for male, now male, if you're male, you're a 1 for the sex variable. So religious school is a 1. So if I'm a male in religious school, it's 1 times 1. So now it's equal to 1. I'm kind of getting it. I'm jumping ahead of the slides. So for male, it'd be 1 times, don't worry, we can just kind of males, it'd be 1 times 1. This dummy variable, or this dummy, well, it's not, well, it's a dummy, but this code, this variable that's part of my interaction, male times religious, is going to be equal to 1. 1 times 0, male times home is 0. 1 times 0, male times private is 0. Then for males in homeschooling, I do male times, when I'm looking at the interaction, this is male times religious, so that's 1 times 0, so that's 0. Male times home is 1 times 1, so that's 1. Male times private is 1 times 0, so that's 0. And then for a male who's in private school, male times religious is 0, male times home is 1 times 0, 0. Male times private is 1 times 1, so that's 1. And then for the homeschooling, it's going to be male times 1 times 0, 1 times 0, 1 times 0. You see how it's very straightforward. You just multiply male times each of those and we're making 3 brand new variables that are our interaction. Now here's some descriptive statistics. Because everything's equally represented, it's equal, it's kind of nice and clean. Male was dummy coded 0, 1. So we know because the mean is 0.5, that tells us half of the kids are male. Religious is 0.25, that tells us 25% of the kids are in religious schools. Home is 0.25, 25% are in homeschooling. Private is 0.25, 25% are in private school. And the balance, 25 tells us 25% are in public school. So we interpret that, everything's nice, equally balanced. When you see something like that, that's just kind of very cleanly telling you everything's equal ends across the groups. If we look at, we first enter child gender, then we enter school type, and then we enter the interaction in 3 steps. You can see that here in SPSS is telling us this is our ANOVA table when we do it in regression. We first enter male, and then here we see the model has male plus the 3 dummy codes for school type. And then in the third model, we have male, the 3 dummy codes for school type, and then we've entered the 3 interaction variables, the 3 terms for our interaction. Degrees of freedom, you can see in the first model, because all we have is male, we first entered male, so the total degrees of, the degrees of freedom for regression is 1. In the second model, now we've added 3 variables for school type, so the degrees of freedom regression is now 4. Right? Gender plus the 3 school types. And then we're adding the 3 interaction terms in the third step. So now we're up to 7 degrees of freedom for our regression. Kind of a few things just to kind of make sure we don't forget. Notice the total sum of squares, again, is always the same. We're always looking at the same total variability in kids' grades. We're just dividing it, breaking it up in different ways. The total degrees of freedom is always the same. It's still 79 because we had 80 kids, 80 minus 1. The total degrees of freedom is 79. We're just breaking it up into what we understand through our regression model and what we still don't understand, which is in the residual. So here we see, from our F, we see the total model with the interaction term is significant. F with 7 and 72 degrees of freedom is 4.697. P is less than 0.001. We go to the model summary table. This is where we see how big of an effect. We know the total model is significant. Now here's where we see, well, how big, though, is that effect? That's the Red Sox just won the World Series. Now we know the score. Right? It took me a second there to... we see the total R squared is 0.313, or the 2 variables, sex and school type, plus their interaction, accounts for 31.3% of the variance in GPA, which is huge. If we look at the R squared change, it tells us this 0.212 is how much the variance, how much additional variance we accounted for in this third model. We accounted for an additional 21.2% of the variance in that third model. Well, what was the third model? That's when we added the interaction term. So here's where we see our interaction accounts for 21.2% of the variance. So the total variance is 31.3. The interaction accounts for 21.2, which is just a crazy amount, but this is made up data. That's how you get the ends all equal. This is our test. Here's where we see how big, well, that's not the test. This is how big the interaction effect is. Here's the test for the interaction. It's an F with 3 and 72 degrees of freedom. It's 3 because we added 3, right? The interaction's 3 variables. Those 3 multiplicative terms we just made. And 72. So with F with 3 and 72 degrees of freedom is 77.419. P is less than 0.001. So very significant interaction that accounts for 21.2% of the variance. Again, here's kind of how we write it all out. So we know we have something going on. Then we look at the coefficient table. We're focusing on the third model where we have the interaction. We know that the interaction was significant, so we want the model with that in the equation. And here's all of our unstandardized regression coefficients. Here's the t-test for all of them with their p-values. Okay? So if we write it, we can write out that whole regression equation. It's kind of long, but you want to write it out. 2.846 minus 0.147 times male plus 0.073 times religious school plus 0.002 times home for homeschooling minus 0.375 times private schooling minus 0.817 times this interaction. And again, as I was saying last week, just to make life easier, instead of writing down the variable, write down how you've multiplied it. So it's minus 0.817 times male times religious schooling, because those are the values I'm going to have to plug in to solve. Minus 0.562 times male times homeschooling plus 0.827 times male times private schooling. So it's a big, messy equation. And just kind of looking at that and asking, well, how big is the effect of homeschooling? Well, there's kind of home here and there's home there and all those other numbers. How do you start to make sense of it? So you can see kind of how it would be very easy to lose sight of what the individual coefficients tell us. So let's go through it step by step.